Hi, my name is Luis Colon and I'm a Senior Developer Advocate with AWS CloudFormation, and I'll be joined by Brian Terry later from our Solutions Architect team, and today we're going to cover new development tools provided by CloudFormation and how to use those relevant tools to develop resource providers. This session is MGT222-P. Let's talk a little bit about what we're going to cover today. We're going to talk about creating cloud resources and creating them with CloudFormation in the context of users of CloudFormation and developers that code on CloudFormation, and how with new enhancements and new tooling that's available from the CloudFormation team, you'll now have more customization options and more programming options with CloudFormation. We'll talk a little bit about the basics of creating resources and some of the coding scenarios that typical CloudFormation users use today. Then we're going to focus on some of these new development tools tailored to creating new resource providers for use with CloudFormation. Then I'm going to have Brian walk through some of the tooling live. He's very brave, so he decided to do it live, so that's interesting. And then we're going to come back and tell you a couple more things about where to take the information that you're going to learn about today, where to go next from here. So let's get started. Let me give you kind of like a little bit of context as to how do we land here. And CloudFormation happens to be one of the services in AWS that's one of the most widely used. It's been around for 7 or 8 years. We manage millions of application stacks for customers large and small. And as those customers start using AWS, when they start, they use just a few resources for applications as they are migrating their workloads or creating new applications in the cloud. It's fairly easy when you're using a few resources to create those resources manually. And AWS gives you the ability to do that through the management console, through APIs, or through a command line interface or CLI. Now, as you leverage more as to like the services and in the resources that AWS has to offer, it becomes a little bit impractical to manage all those resources manually. And this is what infrastructure as code comes in. It is a methodology and a mechanism to be able to define your resources in a text file. We call that a template. And then regardless of how different the resource might be, it could be storage, databases, or compute, you define resources and their properties the same way. And that's pretty much the central use case of CloudFormation. Now fast forward, and if you're a user that's been using AWS for several years, now you may be managing hundreds, thousands, even tens of thousands of resources. Not only does that become more difficult to automate, it also becomes difficult to manage and update. So our customers are always kind of like looking in discussions with us and saying, once I have my very complex and large use cases, what other programmability and coding options can you guys give me in CloudFormation and other services? So that's part of the motivation of what we've done today with some of the programming options that we provide for CloudFormation. And today we're going to talk a lot about how we're extending those programming options. They also want to not only manage their AWS-centric or AWS-native resources, they want to manage non-AWS resources as well. And this sometimes includes resources that they've created in-house, and sometimes it includes resources that they use from other third-party companies, other vendors, other members of the Amazon Partner Network. So the programmability not only applies to the basic resources that you use, but also these other resources as well. AWS invests a lot of money in management and governance tools, of which CloudFormation is one of them, to help with enabling, operating, and provisioning many complex resource cases. So under this context, you have a lot of people that use resources and create them, maintain them with CloudFormation. So at a very high level, the way CloudFormation works is you write the templates in text files, as I mentioned before. You use YAML or JSON, and then you'll generate code either with plain YAML. You can generate code for that YAML with macros and transforms, or you can start with a higher level language, something like TypeScript or Python, for example. And it generates this CloudFormation code that eventually goes and gets uploaded into CloudFormation. In CloudFormation, you don't have to manage the software itself or the engine or the eventual state of that stack. We do all that management for you. When you write that code and are getting ready to commit it, you can upload that template directly via your web browser. You can put them in S3 buckets, or you can pick up that ideally by having that template code be treated as any other type of code with a CI/CD pipeline. Once that template code is presented to CloudFormation, you can execute it. And there's three primary operations there. There's create, update, and delete. And what you're creating, updating, or deleting are stacks, and each one of these stacks has the group of resources that you're managing together. You can create those stacks with the console, once again with CLI or the SDK via APIs. And you can create also stacks across your AWS accounts and regions with a feature we call stack sets. Once those operations are completed, then you'll have those resources created and updated and managed in a uniform way. What's powerful about this is that regardless of the resource being a serverless function or a compute resource or a database, you manage the state and manage the properties in exactly the same way. CloudFormation adds a couple of other benefits to this. It supports dependencies, making sure that one resource gets created before the other. It supports rollbacks, which allow you to, in production, implement a change to a CloudFormation stack. And if there's any issues with that change, we'll remember the last known stable version of that stack, of that group of resource, and automatically revert back to it. There's other CloudFormation benefits that you get from using CloudFormation as your mechanism to implement infrastructure as code and the automation of the creation of these resources. Now, we talked a little bit about this at the beginning in terms of like there's many ways to do programming in CloudFormation, and the basic one that most CloudFormation users are going to use is just use core YAML code or JSON code. In the top left on the screen right now, I'm showing you a little snippet that gives you a sample of what YAML code looks in CloudFormation. I'm defining resources. And there could be a list of several hundred resources here. You name the resource, you indicate what resource type, and the provider of that resource in this case is AWS using the service EC2. And then you may have properties like the instance type of the resource. The templates are built in this fairly simplified common language to kind of like hide some of the complexity of having to create the instance via an API or having to go into the management console browser interface and creating these things manually. So we provide for adding resources, parameters, mappings, outputs, and some intrinsic functions. And like I said, this is the most used, and you'll find that any transformation that you might do from another tool or from another language will result in this YAML or JSON format. And we, like I mentioned before, we have millions of customers creating tens of millions of stacks, and they all kind of like resolve to these templates that eventually are converted into functional stacks. If you want to take the next level up without getting too deep into programming, you can do things like macros or transforms. An example of this is something we developed a couple of years back called the Serverless Application Model, or SAM. And with that, by defining a serverless function, behind the scenes we'll generate the code for Lambda functions themselves, whether or not you require endpoints. It helps with API gateway, DynamoDB tables, and other components. So you can use this much like you would use a macro shorthand and in other applications. Write a fairly small macro and let the macro itself expand the code to the final version of the code. We released the macro functionality in general last year, and there's a lot of customers right now using it to add functions to the language, for example, a looping function. For people that want to develop in a less declarative and more imperative way, we also provide options for you to develop in common languages. Examples include Python, JavaScript, TypeScript, other languages, and then these things will start with your language and with your language syntax, which you can leverage in your IDEs and plugins on the IDEs, and then generate the same YAML and JSON code that the majority of users will end up using. One note, an example, a recent example is CDK. It's a cloud development kit that was released with AWS earlier this year. and it's designed to be used for multiple high-level languages. On the open source side, there's many options also to do this. A notable one is Troposphere. That is an open source project that uses Python as the high-level language and generates CloudFormation, YAML, and JSON code. Now let's talk about custom resources, because these first three options are more about building on top of existing resources that are available for CloudFormation today. CloudFormation has about 420 to 430 different types of resources that you can create. Again, compute, databases, etc. And in many cases, there's resources that we don't yet support because they're new. There's resources that customers have that they're their own custom homegrown resources on their applications. And there's many cases there's resources from third-party vendors and providers. And this is where today you use our custom resource functionality to actually create those within CloudFormation and together with other CloudFormation native resources. The primary method to do this is using AWS Lambda. And if you think about what's involved in creating and maintaining a resource, we'll essentially use this custom resource to create using like a create API call, update, delete, and those kind of like CRUD events to create those resources. So let's dive deep a little bit more about how custom resources work today, because it helps introduce some of the significant new things that we're doing in terms of customizing a CloudFormation from that model. Today's version of custom resources uses primarily Lambda, which means that you can use any of the available Lambda language to create your custom resource wrapper, if you will, that creates, updates, or deletes those resources. There's also a way to do it with Amazon SNS. In the same way that you have to handle the events for creation, update, and deletion, you would have to create or program handlers for those events. Most validators, once you actually write your code and you implement your custom resource code inside of an existing CloudFormation template, you want to run through validation. One of the projects that we released last year was a linter. It's on GitHub as CFN lint, and it obviously will recognize all the 400 or so resources that are native to CloudFormation. But if you're creating customizations, those pieces of custom code will not be validated by the linter. But you do have the ability with CFN linter to customize it to create your own custom validation rules. You'll notice that in the snippet on the left, I've called out an example on how would you, once the custom resource is created and the Lambda is deployed into your account, you would call that custom resource with the custom : namespace. And then you would pretty much type your resource name. Here's a very basic example of an AMI info custom resource that you can use, for example, to get the latest ARN for a particular AMI image. In comparison to native resources, building and deploying custom resources can be cumbersome, if nothing else because A, they're not going to look exactly like native resources like EC2 or S3, but also from an invocation standpoint, you're really building and executing and controlling and maintaining a Lambda. And it's up to you to obviously manage things like versions and updates to that code, and then account for whether or not your code is going to be backwards compatible to previous versions of your custom resource. Custom resources, however, have become something that is widely used, especially by larger customers that have very complex application environments, and they have that mix of AWS, non-AWS, partner resources, third-party resources, and even resources that they picked up from internal sources or even open source. So you'll find, if you do a search online, that there's many public and third-party custom resources available out there, mainly on GitHub. So now that we've established some of these programming scenarios that we have in CloudFormation, let's add a new programming scenario, which is now building resource providers. When you're building custom resources, you're probably building a specific resource type. With this resource provider, now we're expanding that to build really types and groups of resources and build them in such a way that they can be written with more tooling, with less effort from a programming side, and also in terms of when you're invoking these things, they'll feel like invoking native AWS resources. So this is where the new tooling comes in. I updated the sample code on the left-hand side to to kind of like a sample invocation of what a new resource provider built with this tooling might look like. The first thing that you'll notice is a difference in namespace. Most CloudFormation code looks like AWS : service name resource type. And as we talked about in the previous slide, custom calls look like custom : resource type or resource name. Now we add that the ability to name resources by organization, whether they're your own organization, whether it's a third-party vendor, etc. So the first thing that we do with these tools is we're expanding the namespace beyond AWS : in terms of like handlers, event handlers, we now expanded from only having create, update, and delete to also having list and read. Now this will become important and will for reasons that I'll mention on the next slide, but with more control about those events, that's what empowers those new resource providers built with this tooling to be invoked and managed in a more native way to CloudFormation. But what is central about this, in terms of like defining those resource providers, is now we're kind of like standardizing on JSON schema-based modeling. What that means is that you start with a JSON file where you define things like the name of the resource, what are the total properties, the default properties, the required properties, the data types for those properties, permissions, and etc. By having that definition, you're going to get two key benefits. Number one, based on that definition of schema, we're going to be generating a lot of the scaffolding and the code and the assets that you need to complete all these components of creating the handlers and defining dependencies, etc. And also, because it's kind of like all based on this model, we can add to our resource specification based on your JSON schema model, so that when you use tooling to validate or to author code like the linter that I mentioned before, that linter is going to recognize that like it would recognize any other CloudFormation native resources. So you're already getting a couple of benefits even early in the authoring stages of creating custom resource providers. So what does this first-class native experience look and feel like? What does that mean to you? Well, when you're creating custom resources, you're creating Lambda functions. And those Lambda functions, you'll need to create them either with creating the function directly, using our serverless transforms to generate that function code. In many cases, you need to worry about the execution roles associated with them, and that's where you start defining the permissions that function is going to require as it handles events like create, update, or delete. So there's a little bit of things that you need to do, as we discussed when we were talking about custom resources, a little bit extra work, because it's not only now deploying the resource that you want to deploy, but also deploying the Lambda that actually controls the creation of that resource. Here, once you create and submit this resource provider to our resource provider or CloudFormation registry, that invocation and the use of that resource looks exactly the same as with native resources. So what does that mean to you? If you build new resource providers for submission into the CloudFormation registry, and with this new resource provider tools, you'll get to inherit a lot of the benefits and features and feature enhancements of CloudFormation. What that means is if you use this tooling, it automatically supports rollback in the same way that we roll back our AWS native resources. When you are looking for a plan of changes before doing an update and creating a change set, that resource provider is going to be smart enough to also send events for us to populate that change set for you. As you start using tooling like CDK to generate your CloudFormation code, those objects that you're creating as resource providers will be available to the CDK, since the CDK is also using the resource spec as a base to indicate what kind of like resources are supported there. And that's just the beginning. When you talk about other kind of like unique features of CloudFormation like stabilization and integrations with other services, all of those things, all of those integrations, and all the events that are emitted from CloudFormation for those integrations are going to be the same kind of events that automatically will be emitted from your resource provider when you use them with these tools. So you'll see over time, as we are creating even more features, if you are using this tooling to create your resource providers, they will inherit a lot of the benefits of those new features as well. So there's like three key components to this new tooling that we're releasing. The first one is a core library. we start with Java. What we plan to implement, we design it to be language agnostic. So from a perspective of the options that you'll have to create resource providers with these tools, you'll be able to create them with Java, with Python, with Go, probably C# and a couple other languages, either at launch or very close to launch. And then you have this CloudFormation CLI command line tool. Think of it as a local tool to be able to say, when you initialize a project, it quickly scaffolds a code project and adds some of the required files like your JSON schema file, your deployment file for Maven in the Java example, and others. And it kind of like gets you started and makes you focus only on the required code for your event handlers. Like I said, create, update, list, describe, and delete. So it does help with code generation. It allows for local testing. We're doing things like leveraging some of the functionality available with SAM Local, which that allows you to, even in a local environment, do some testing and leveraging Docker behind the scenes, not unlike how you would do local testing with SAM for Lambda functions. We talked about how it makes validation a lot easier because it's generating from a particular model. And then it automatically allows you to submit code to CloudFormation. And what submit means in this case is that once your code is tested and validated, it will be registered into this service that we call the CloudFormation Registry Service. In the beginning, it's going to allow you to enable your custom resource provider, once they're registered, to be shared privately across users in your account. And there's going to be other sharing models that we're planning to enable. Since we're also planning to allow you to use, for example, third-party resources, those will either be things that you can register yourself, and over time we'll integrate those resources into the registry, and the registry will be the combination of all AWS native resources, non-AWS resources, your own resources, and third-party resources. So that registry is going to be the main delivery mechanism to be able to leverage a lot more beyond the 400 or so resources that CloudFormation supports natively today. A big part of our strategy here in developing this tooling now and going forward is us embracing the open source community. Much like we started to do last year with tools like the linter that I mentioned before, the CloudFormation CLI tool that you're going to use to generate some of this code will be open source. Not only that, but we plan to open source most of our native resource provider code with several of those resource providers available as we launch this new tooling. And that's important because you'll be able to see not only how you'll be able to experience the fact that your custom resource providers are going to operate and be invoked and be managed just like we do for our native resources, but you'll see kind of like the provisions and the security and the techniques that we use to write our own resources. So the idea here is that you can use that as a starting point to bring that same level of quality and predictability to writing your own custom code. We plan to encourage our community on GitHub to implement and share resource providers when it makes sense. Many of our customers are going to want to have their own private resource providers. Many of them will probably look at different combinations of resources that they want to either create their own custom implementation for it, or even a combined implementation of more than one resource. And we want to make that as open and as transparent as possible, because I think everybody will benefit from that, because this in reality is really opening for the first time the execution and management engine to CloudFormation so that your own resources feel like native resources. So let Brian walk you through some of the tooling that I've talked to you about so far, and I'll come back after he's done.
Thank you, Luis. My name is Brian Terry, and I'm a Senior Solution Architect at Amazon Web Services, and I'm excited to show you the demo of our new feature in CloudFormation. In this example, we're going to build a custom metric filter. I chose this example because it's fairly easy to implement, and it also shows how you can extend existing CloudFormation resources to meet your own demands. So what we're looking at is an existing CloudFormation resource, and let's dig a little deeper into this. As you can see with the resource, it has various properties that the end user has to implement in order to deploy this resource. So what we're going to do with our custom resource is we're going to create one that models this. And I'm going to show you how this works from end to end, and we're going to test this. So let's begin at the beginning. First thing we need to do is install the CloudFormation CLI. I've gone ahead and installed that for the sake of time, but for now, we can just move ahead. And the first thing we need to do is create a project folder and cd into that directory. So let's do that. So for my project folder, I'm choosing the name Brian Log Metric Filter, and I'm going to cd into that directory. Now that we have our project created, our project folder created, the first thing we want to do is initialize our project. So we're going to use the CloudFormation CLI, and we're going to run the init command. So let's do that. When we run this command, it's going to ask us a couple of questions about the resource we're creating. It's going to ask us essentially what is the name of this resource. Will be the first thing it asks. So for this organization name, I'm going to use my own name, Brian. And for the service, we're going to call it logs, and the resource is going to be a metric filter. And then it's going to ask us what language we're going to create this resource in. I'm going to choose Java because it's the default language for this plugin. Next, it's going to ask us what do we want our package name to be. And I'm going to keep it the default and press enter. So after I run that command, the CloudFormation CLI has generated some scaffolding for a project for us to create a resource. So let's dig a little deeper and take a look at this folder structure. You'll notice inside our folder, it's created a Maven project. And you will see that it created all the scaffolding we need in order to get started creating a project. So what we need to do is import this into our IDE. So we're going to import this into our IDE. It's worth noting that because this is a Maven project, you need to import it as a Maven project, or your dependencies won't get recognized in your project. Well, I've gone ahead and done that, and I'm going to be using VS Code for this project. And I've already installed the VS Code Maven plugin, and we should be ready to go. So let's do that. Alrighty, we have our project open now. So let's take a few minutes to dig a little deeper into our project. The first thing you would notice that the scaffolding has created your standard Maven layout that you're used to if you've been programming Java. And within this scaffolding that the CloudFormation CLI has created for us, it's created a sample schema for us. It's created some sample source code so we can get started, which is including some scaffolding and some boilerplate code for all our handlers that include create, delete, list, read, and update. And if we dig a little deeper, it's also generated unit tests for us. And you will notice that these unit tests are using standard Java JUnit tests. So this allows you to have certain code coverage for your resources. And they're provided, and the CloudFormation CLI has provided all the scaffolding for you to allow you to develop this resource quickly. So the first thing we're going to do is let's take a look at the schema again. And you will notice that the developers of this command line tool have included an Easter egg. And let's see if you can spot that. But what I will say to you about this resource is it will help you generate a great TPS report. So the first thing I like to do when I'm creating these projects is validate the schema first. You will notice that your project is laid out as a standard JavaScript schema, JavaScript schema, your standard schema. So what we need to do is validate this schema. And you can do that anytime by running the command CloudFormation validate with using the CLI tool. So we'll validate that. If you're new to JSON, the JSON schema standard, you may want to do this often when you make small changes to your schema. So now that our schema is validated, we'll go back to our schema, and we'll get rid of this boilerplate code, and we'll add a schema that is specifically designed for our resource. So let's dig a little deeper into the schema. What we have here is we have a JSON schema, and we've created properties for our schema, for our resource. And you will notice that our resource has within these properties, we have defined types for each properties that include numbers and strings. And we've also provided some validation on these properties by using a regular expression, or either a max and minimum for strings and numbers. And if we go down further, looking at our JSON schema, that we've defined fields that are required, which include the filter name, the filter pattern, the log group, the metric transformations, and we also have included a primary identifier. And if you look at the bottom of our schema, we've defined properties or permissions that allow our handlers to access things within our AWS account. Since we're going to be creating a CloudWatch metric filter, we need to be able to make API calls to the CloudWatch APIs. To do this, our handlers need permission to do that, and we define that in our schema. So once we've created our schema, the next thing we want to do is use the CloudFormation CLI to convert our schema into a model that we can use within our handlers. Because this is a Java project, this generates your standard Java model. So let's do that. All right, and we'll go back to our project. And now we've generated our model. The next thing we need to do is, because we're going to be using the AWS CloudWatch Logs API, we need to add dependencies in order to do that. And because this is a Maven project, we do that in our POM file. So within our POM file, we're going to add a dependency for that SDK. All right, and we're going to save that. And now we've added our dependency. So just to recap on what we've done so far. We've used the CloudFormation CLI to generate a project. We've edited our schema. From our schema, we've generated a model that we can use in our handler functions. And we've added our dependencies for this project. So next thing we need to do is implement the handlers. And a good place to start would be the create handler. So let's do that. So again, we're going to get rid of this boilerplate code. And we're going to add our code to create the log metric filter. So let's take a few minutes to take a look at this code and kind of walk through it. So in our create function, CloudFormation hands us a model of a desired state in which the user has defined when they create our resource. And what we're doing is we're getting that from the getDesiredResourceState function. And then we're creating a putMetricRequest object, just like you would do using our AWS SDK using the Java language. And from that, we're using the getLogGroup method, the getFilterPattern, the getMetric transformation, and the get method for the getFilterName. And in the next section, we're generating a standard AWS client. But this is where it gets a little special. We have a special project object, and this is a object that abstracts handling AWS credentials. Those permissions that we defined inside the schema are automatically pushed into this proxy object, and this method is invoked on our behalf without handling AWS credentials. Again, this makes your life a little easier in developing these resources. So this proxy will execute the putMetric filter request on our behalf and inject the credentials for us. The next thing we have to do is return a progress event. And inside our progress event, we have to return a couple of things. One is the model that we have in our function. So you can adjust this, or you can just return back the same model that CloudFormation hands to us. And you have to return an operational status. And valid status for this include success, failed, or pending. So now we have our create handler created. The next thing we're going to do is look at the delete handler. Because if you're going to create a resource, it kind of makes sense that you want to clean that up. So again, just like in the create handler, we're going to delete all the boilerplate code. And we're going to paste in our delete code. And let's take a few minutes to step through this. So in our delete handler, we're doing the same thing. We're pulling back our desired state from the model. We're creating a delete metric filter request using some of the fields in our model. We're creating your standard AWS client. And once again, we're using the proxy object in order to invoke the delete metric filter request. And last, we're returning the progress event that includes our model and our status. And we'll save that. Alrighty, so in your project, you may want to go a little step further and implement some unit tests, and maybe, just so you can meet your code coverage. But for now, we're just going to skip that and move on. So the next thing we're going to do is build our project. And we do that by using a standard Maven command, because again, this is a standard Maven project. So we're going to use mvn package. And when we run this command, this is actually going to run our generate command from the CloudFormation CLI, and it's also going to run our unit test. Great. Our project built successfully. So the next thing we have to do is submit this to the CloudFormation service. And we do this by doing the cfn-cli submit. All right, our project has been submitted successfully. So let's go back to our project. Now that we've submitted our project to the CloudFormation service, let's test it out by using it in a real CloudFormation template. So what we're going to do is create a CloudFormation template. So what we're going to do is create a file in our project folder, and I'm going to call this cfn.json. All right, and inside this CloudFormation, I'm going to create a CloudFormation, your standard CloudFormation. And let's take a few minutes to analyze this code. So in this CloudFormation, I'm creating two resources. The first is a log group, and the second is our custom resource. The log group is your standard AWS log group resource. And the next one is our custom resource. And you'll notice that we're using a namespace that I created for my custom resource, which is Brian Log Metric Filter. And we're getting the group name from the log group that's located in the same CloudFormation. And it's worth noting that our custom resources can use all the CloudFormation's intrinsic functions just like native resources. So we'll save that. All right, so now we have our project. So now let's deploy our CloudFormation template to see if our resource works. So we'll go back to our console, and we'll go to CloudFormation. And let's take a look at our resource type in the console. And as you can see, we have our custom resource here inside the console. So it's active and we can use it. So let's create a stack. So I'll go here to create stack. I'll upload the template that we just created. And I'll click next. We'll give it a name. We'll call it My Filter. And click next. And we'll go with the standard options for right now. All right, and we'll validate that and we'll click next. All right, so let's refresh the page to take a look at the events. So the first thing that was created was the log group that we defined in the CloudFormation template, and it created successfully. So as we refresh, we'll see that our custom resource is being created, which is a filter. And we'll refresh the page. And success, our custom resource has been created. So let's go into the AWS CloudFormation console and take a look at this resource. So if we go to AWS, and then we go to CloudWatch, and we go to CloudWatch logs, we'll see that our metric filter group has been created, and we have attached our custom resource, which is My Filter. So now we've created our resource, let's test out removing our resource. So let's go back to the CloudFormation console. We'll find our filter stack, and then we'll delete it. And when we do this operation, this should call our delete handler. So looking at our stack events, if we refresh the page, we'll see that our stack has been deleted and our resources have been deleted, including our custom resource. So to recap on what we've done, we've used the CloudFormation CLI to generate a project with scaffolding. We've edited our schema. We've created a model for our schema. We've included our dependencies in our Maven project. We implemented the create handler and the delete handler. And we created a CloudFormation template. Once we did that, we launched that template, and we created our custom resource within our AWS account. And then we destroyed that resource. So as you can see, using the CloudFormation command line tool will allow you to quickly develop custom resources. And I'll hand it back over to Luis.
Thank you, Brian, for that demo. Some things to highlight. Notice how, although we created a custom resource, we were able to create a new one and delete it. All the sequence of events in terms of deploying it, writing it on the template, and looking at events on the interface on the CloudFormation console looked exactly the same as operating, creating, deleting any native AWS resource. And although it wasn't completely seen there, other options like generating a change set or doing a rollback, because you would be using the same tooling, it's very similar to the tooling that we use internally, you get a lot of those benefits. So to close out, this new resource-provided tooling provides about the most coder-friendly automation that we provided in CloudFormation for you to create your own custom resource providers. Not only doing that, but also allowing you in a single template and in a single stack to manage AWS, non-AWS resource types, third-party resource types, your own company's resource types, etc., while leveraging those unique benefits like we talked about before, rollback, stabilization, and as we integrate or have integrated as well with other management and governance services, in the same way that those integrations work with those CloudFormation events, native events and everything, those custom resources and those custom resource providers are generating those events as well. And as we improve and add on to those integrations, tools, custom resources that I built with this tooling will inherit that and will be on the registry available for all your remaining users in your accounts and in your organization. We expect all customers and developers to benefit not only from us open sourcing the tooling itself, the CloudFormation CLI that Brian showed, but also from open sourcing some or the majority of our native resource providers, so we can all, together with you guys, build resources that are predictable, of high quality, that are deserving to be CloudFormation first-class citizens from that resource perspective, and really get to the benefit of managing and automating the management of non-AWS resources alongside AWS resources. So where do you go from here? A couple of suggestions. You should start with perhaps the looking at CloudFormation projects on GitHub. Well, you see the project for the CFN CLI, where you can see how we're improving that tool, and you guys can also help us improve that tool. When it comes to getting more information as to how to operate these tools that we demonstrated today, you can go to the CloudFormation homepage and check out our documentation. And in the same way that you can leverage a lot of these CloudFormation native abilities when you create these resources, you can also leverage many of those CloudFormation integrations with other management and governance services. For example, AWS Config would be one that comes to mind. And if you want to get some help or want some questions answered by many AWS folks, including people from the CloudFormation services and solutions architect teams, you can join our Slack channel. For that, you can direct message me via Twitter, Luis Colon1, or my fellow developer advocate colleague, Dan Blanco, with your email, and we can add you to that Slack channel. We have a fairly active community with over 1,400 users in the community. So we definitely want you to kind of like take some of the information that you've learned about today, think about what cases it makes sense for you to implement these tools with. Rest assured that the remainder of the things that you built with CloudFormation before, even with the non-resource provider custom resources, will continue to work, and we'll continue to support that, as well as the other programming scenarios that we talked about today. And with that, I'd like to thank you and thank Brian, and hopefully this has been very helpful for you. We can't wait to see what you guys come up with this new resource provider development tools. Thanks so much.